Good morning all. My presentation that is on a new horizon of utilization of bamboo for production of food packaging, pulp, paper and board. Since morning we are listening the lectures on the different topics, food packaging based on the recycled fiber. So my presentation is focused on virgin fiber, that is bamboo we are using. And before proceeding to the presentation, I would like to show the current status of Indian pulp and paper industry. We all are aware of that the numbers which we have in terms of the total production, 21.36 million tons, that of figure of 2021, and per capita consumption, that is 15.63, which I feel that will be on higher side by coming years. And the wood based and agro based total segment that is covered under this 21.36 million tons, that is around the agro based, they are less than 10%, and the combined 6 million tons, that is very shrinking the virgin fiber utilization. And for food packaging, while we are talking about that, there are so many issues related to, like odor problem is there, and then contaminants related to ink and other. We are focusing that why not to use the abundant natural fiber like rice straw, bamboo, wheat straw and bagasse, and molded products, they are coming in the market. We can see the scenario that earlier the time that when we used to order the food from the Swiggy or Zomato, that was the plastic packaging they used to supply it. And recently when we ordered the biryani, that was in a molded box, pulp box. So being a paper pulp technologist, I feel proud to that the market and the consumer shift towards the environment friendly products, molded and different. And I feel that this segment will be grow because of the number of factors. So there are various food packaging substances, like there are reason for packaging. There are heat sensitivity, and then processability, printability, then barrier properties, cost effectiveness, sustainability, and material like paper, plastic, glass, aluminum, wood, and the combination of these are used for food packaging. And paperboard encompasses 31% of global packaging market segment, and most widely used for food packaging, contaminant projection of the food product, convenience for the storage, consumption and communication of the relevant information to consumer, including the marketing aspects. So the growing market of pulp and paper based food packaging is there, and food packaging market is rapidly increasing after the ban of single use plastic. That is the most driving force actually, that is shift towards the cellulosic fiber for food packaging. And the contaminants like ink and the surfactant, bleach chemical, those are there in the recycled fiber, which are health hazard. And direct food contact, which is actually edible in the form, that FSSAI have advised to use a virgin grade packaging material, pure cellulosic material. And there is a because of that there is growing demand, and the global biodegradable packaging market is expected to grow by CRG at 20.8% during the coming years. You can see the Asia Pacific food packaging market, which is steadily growing. And there is then, if you compare with the in Asian context, we have a very food packaging market that is actually 7% in India, the value addition to 7% as compared to the China, which is where it is 23%, and in Philippines that is 45%. So we are quite behind that in that segment. And paper and paper board are used for a number of variety of products, like board in form of board, in molded board also. And you can see the different type of food packaging paper boards, like papers and board. And there are wrapping tissues are there, their specifications are there. And the board as high as 400 GSM and 1600 GSM for solid packaging. And then the confectionery item, chocolates, and there is wax paper, which are so number of variety of packaging, food packaging material is there being used for packaging of the food. And here we have carried out the study why we have selected the bamboo. The reason is that the Government of India advisory after that bamboo is no more a forest product. We can use bamboo, and bamboo is a very well-known raw material. There is the composition of bamboo, the fiber length of the bamboo. We can, in a different manner, we can use as a various processes, and the pulping process wise, and we can have better benefit of yield also, and strength wise also, because of the good fiber length. And the Government of India initiative that has restructured National Bamboo Mission, that approved by the CCEA in 2018. The government is providing subsidy also. So we have in abundance of bamboo fiber. And not only bamboo, we can use any other agro crops like rice straw, that is there available in plenty. And for the products like molded fiber products, we do not require much strength also, and very limited these properties. And we can replace the recycled fiber very well with that of natural fiber. And there is the experiment we have carried out for various end uses, like before that, I would like to show the chemical analysis of bamboo. We have a very good amount of whole cellulose, that is around 75.67%, and the length is 1.8, very good fiber length. And lignin is there in 25%. So we are not talking about the very high grade writing printing paper. We are talking about the packaging grade paper, packaging, that is virgin pulp, food packaging pulp, and molded product variety pulp. So we have carried out the study for all three segments: chemical pulp, semi-chemical pulp, and chemi-thermomechanical pulp. That is the based on their end uses. And here we have shown the bamboo chemical pulp properties. You can see that very good strength, and bus is after refining we have a bus as high as bus index 4.6, and tensile, that is 70. So low GSM packaging or carry bag for food packaging, that can be produced with the unbleached kraft pulp of chemical pulp of bamboo. And then we have carried out a study on semi-chemical CTMP process. CTMP is a very good process. We can have very high yield, and in molded products, since we are not aiming for very high brightness also, now the current scenario is that the market pulp which is available is a chemical pulp. Chemical bagasse pulp is there, and mixed bagasse BT straw pulp is there. And chemical pulp, we have a low yield around 45 to 50%, while in case of CTMP we have very high yield also. And since we are applying the barrier coaters there, and the benefit of high yield we can have, that is 75% in case of rice straw, and in case of bamboo you can see the 77 and more than 75% we have yield in chemi-thermomechanical pulping. Even if we go for bleach single stage peroxide, we can have 60% or 55%, which is ideally okay for molded products. So we are suggesting in CPPRI, we are having infrastructure for optimizing the CTMP and BCTMP conditions. And not only bamboo, other raw material also we can study. And we suggest to use instead of chemical pulp BCTMP for molded products and as a replacement of other the market pulp available, and the semi-chemical soda and semi-chemical we have studied with low chemical dose and then high chemical dose also, and semi-chemical NSSC pulping also we have carried out. You can see the yield difference there, and the process that involve two-stage process. That is, first stage is the pre-treatment of the raw material, and second is the refining of the that is mechanical treatment to produce high yield pulp. In both cases, CTMP and semi-chemical pulp, and accordingly, as per the we give the chemical treatment, we have the better strength properties, as we aware of that, and accordingly the unbleached pulp brightness also have better in case of sulfide pulp. NSSC pulp is a very good process for packaging grade, food packaging grade pulp, and for carry bags also, for even for molded product also. So there is a physical strength properties of semi-chemical and CTMP of bamboo we have carried out. So you can see that as we understand the molded product, CTMP, that requirement is burst index around 1 to 1.5 in the range of, and that is of 200 GSM board, that is. So that is easily attainable with very low chemical dose applying, and many of the entrepreneurs, they are using no chemical kind of concept, but we suggest to impregnate the fiber, swell the fiber, and you will have better strength and low reject content, and formation is also better. So being a researcher, when we feel that someone comes and asks for a process optimization for their end use, we go for reverse engineering, what are the end product, what property we are aiming for, and accordingly we change the process and we give them solution. And we are very happy to say that number of startups, actually small, this is not basically we aim for a 100 ton or 200 ton, but a small 5 ton or 10 ton plant, we are providing complete feasibility study starting from the raw material preparation. That part is also very important. And for bamboo, we can say that not only the intact bamboo, the dust of bamboo, like those agarbatti makers, they have 1 ton of per day they are throwing the bamboo dust, and that can be very well used for the production of molded products. So in a wholesome, we are taking the different segment of the society, those they can use
Madam, little speed up.
Yes, sir. The fiber like bamboo, and not only bamboo, the other fibers also. So those facilities are there in CPPRI. This is a part of my student thesis work, so not much data we are exploring here, but anyone who interested, they can go for optimization and process optimization condition at CPPRI. We are very good facility of in different areas, and we can address the issues. And in conclusion, I would like to say that bamboo being an annual crop, it may be juvenile bamboo also can be used, bamboo dust can be used. So being a long fiber, we have very good freedom of using bamboo, and it can be utilized for a replacement of recycled fiber. I am not challenging the manufacturers who are using recycled fiber, but we know the problems are there, and if we are having a concept that we can replace the natural fiber and we can use the natural fiber, like the problem which is very common, you may ask that what about the effluent with the semi-chemical pulping and CTMP. So my answer in advance, I will say that in the similar premise, like ITC, they have their filler grade pulp. We have done optimization study for them in the same premise. So there is no issue for the effluent. And if a mill which is having a line for craft line, and the effluent coming from CTMP plant, they can very well use there. And we also have the closed loop and different segment, like pre-treatment effluent we can recycle for washing, and there is a very limited limited effluent quantity, and a small plant, if 5 ton or 2 ton or 3 ton, that effluent can be manageable. And we had complete study of water this balance and material balance, and the complete feasibility study up to 5 ton plant. So if anybody is aiming that, they can approach to us. And with that, I would conclude with that the food for thought that started by Mehta sir and then continued by Dr. Ashok also. So food for thought for food packaging. That is my the concluding remark actually, so that we can understand the core requirement of various end users of food packaging and the replacement of the fiber, and to have a perspective for adoption of process which has better economic and environment viability, and a patriotic sentiments of Atmanirbhar Bharat and circular economy to support the farmers, to help the sustainability in different segment of food packaging, to avoid the import of the fibers, and to make sustainable our industry. I would suggest to use a natural fiber as much as possible. You will have to think out of the box actually, and that is the food for the thought. Thank you very much.